Okay guys, I'm trying to make a video to give you some support since I'm going to be out of town. One of the things I'd like to address with you is when you worked through page 14, there was a lot of worry about what was internal or external to the system, and so I'm going to tell you that if I look at this right here, I'm going to say the ball in the earth. It's important for you to remember that in order for something to have gravitational potential energy, which is EG or UG, in order for it to have that, then you have to remember we said that that was dependent on mass, right? Height and gravitational field strength. So you can tell that I'm in a one down position with the drawing. So gravitational potential energy is, says proportional to, but is dependent on this. So boy, I really don't understand that. I wish that could go somewhere else. Anyway, so there was also some confusion on the idea of potential. Really, the way I'd like you to think about it is potential energy is stored energy. Okay, so I'm going to say it like this. Potential energy is stored energy. And while chemical and electrical and magnetical can all be stored energy, the ones we're going to deal with the most are gravitational potential energy. I can't write everything you need to know, but you can be jotting these things down as you watch it, right? So potential energy is stored energy. Gravitational potential energy is stored between the earth and that object, right? So when the ball is up here and the earth is, down here, if I lift the ball up, I invest energy, right? I move this mass through this height against this gravitational field, and I store energy between the ball and the earth. If the earth is not present, there cannot, or some other planet, there cannot be gravitational potential energy, okay? The other kind of potential energy that we will deal with most frequently is elastic or spring. Okay, those are the same thing. All right, all of a sudden I don't have a pen anymore. I'm sad. Come on, pen. Don't do this. Elastic or spring. Okay, so I'll say E spring, which is elastic. Okay, so those two are potential. All right, the next thing is kinetic, and kinetic energy is when something is in motion. Okay, so there's kinetic. So it's just some confusion with terms, okay? So there's kinetic, right? Right? Oh, that was a very pretty curved line. So EK happens when something's moving. All right, so there are these three that we're going to use just all the stinking time. And these three, oh look, somehow I've done it again. These three, I hope y'all are watching this on like triple speed. These three are I know it's painful. I wouldn't do it if I weren't going to be absent, but I'm trying to help you out. These three are mechanical. So these three make up, I'm just going to say it right here. These three are, right, mechanical energy. It's a strange little box I'm writing with, isn't it? Okay, so anything interesting, anything that's not this is not mechanical. So that's kind of supposed to be a C. All right, very terrible. Okay, and then we have one more over here that is, I'm just going to say thermal. Okay, you know it can be dissipated or internal. That's all the same. Yeah? So E thermal. And that is not mechanical. Gosh, I bet everybody in here knows. Gee whiz, really? Okay, that's it. Thermal is not mechanical, okay? I'm sorry. It's as painful for me to do it as it is for you to watch. So what I would say, so there you go. Those are the energies. In addition to that, I would say that there's been angst, trouble, fretting about internal or external to the system. In this case, I'm going to have the ball and I'm going to have the earth. I can't write more than the letter, guys, so I'm so sorry. Ball and the earth, right? And they are connected through the earth's gravitational field. And then I would put, some sort of a dashed line, and I'm saying, hey, the ball and the earth are in the system. So the problem can tell you what the system is, or you can choose the system. If, for instance, I had some cat fur over here, right? And the ball were also connected to the cat fur. Now the cat fur is external to the system because I'm saying the system is just the ball and the earth. I'm declaring it. Now the problem could say, hey, your system is the ball and the earth and the cat fur. Or your problem could say, hey, the system is just the ball. If the system were just the ball, guys, then it could not have gravitational potential energy because you have to measure the height from somewhere. So if you just have a ball, or even a ball with cat fur, you're not measuring it from any planet that offers gravity. Okay? So I would encourage you to get some sort of a template for these circles. I have left out some cylinders. Some of us used quarters. There may be some quarters left out. You can freehand your circles, but it's easier to have a template. Okay? So if we look at the top, again, I have a choice. I've said if you go to the hints that are on Canvas, they're on Canvas under, is it course unit something? What is it under? I sent a
Resources?
yeah, but I mean, what's it under? Like if you go to home,
You go to home, you just kind of follow the
no,
current.
something. I sent a remind. What did I say? Course unit. That's it. So go to course unit and you'll find hints. You'll find our calendar, okay? So if I go up here, and in the hints, I said no air resistance on this one. I just declared it in the hints, okay? So if you go up here, it could be moving when it starts or not. It doesn't tell us. So I assumed, you could have chosen something different, but I assumed that it was moving when it started. Okay, so I'm going to say this is green is kinetic energy. So I assume that it's moving when it starts. And so it has kinetic. Right? And so I'm going to color this by in here. And then I say the rest of it is potential, gravitational potential, right? So E, G. Right? And so the rest of this is EG. And if we get in here, we move to like this spot right here, which is B. Then I'm going to say, hey, maybe there's some more gravitational potential. Doesn't necessarily have to be half, but we'll say this is, I'm sorry, not more gravitational potential, more kinetic. So here's the gravitational potential, but our kinetic has increased because our gravitational potential is decreased. We're less high, but we're faster. Yeah? So that's it, okay? At the bottom, we have a choice. On my key, I said, apparently I can't see. On my key, I said that it had a little gravitational potential at the bottom, but that it was mostly kinetic, okay? So it's going really fast. Sorry, this is terrible. It's going really fast at the bottom. Now it's becoming comical. Who's the artist that draws like that? Do we have any art students? Some of that scribbly stuff doesn't really look like art to me. But I said to myself, that it is moving, it has a little bit of velocity at the bottom, right? So it's right down there. It's almost, oh, I just spoke about this wrong. Lots of velocity is green, a little bit of height at the bottom is red, right? Would it have been okay if you had drawn all green and said it was encountering the bottom, it had no height, it was going the very fastest? Sure, that's a personal choice. Okay, thanks a lot. Next part is